When the sampling rate of a digital scope is not high enough to fully capture the details of a signal, you can use peak detect to help capture the envelope or narrow pulse information that may be lost when using normal acquisition modes. Let's compare normal mode and peak detect mode. In this example, we are using a Rigol DG5000 arbitrary waveform generator to output a signal with 1 kHz frequency, 5-volt peak-to-peak amplitude, and a 10 nanosecond pulse width. The signal is connected to channel 1 of a Rigol DS4000 oscilloscope. Adjust the time base of the oscilloscope to 1 millisecond per division, the vertical scale to 1 volt per division, and memory depth to 140 kilopoints. As you can see, the default acquire mode is set to normal. With this setting, there are some pulses with different amplitudes and the display is not very stable. This is because the oscilloscope samples the signal at equal time intervals and uses these samples to rebuild the waveform. Using this technique, the peak of the signal may be lost. Keep the other settings, but change the acquire mode to peak detect. Now the amplitude of the pulses are fixed and the period of the narrow pulse is 1 millisecond. This is because the oscilloscope acquires the maximum and minimum values of the signal within the sample interval to capture the envelope or the narrow pulse details that might be lost using normal sampling techniques. Here are some key points for setting peak mode. Configure the vertical and time-based scales to capture the signal. Then choose peak detect mode to get more accurate information about narrow pulse or peak features within the signal. Thank you.